Number 18, your classic pendulum question. You've got a pendulum, you pull it back and you release it. And this specific question is asking for the kinetic energy. So the pendulum is up here. At this point, it is all potential energy. And then it's going to go down here. As it goes down here, the kinetic energy increases, the potential energy decreases. And at this point, it becomes all kinetic energy. And the question is asking for the kinetic energy at this point here. All right, so in these kind of questions, they can ask you for the potential, the kinetic energy or the velocity at the lowest point. They could also ask for the velocity at any point in between, which makes it a little more difficult. But this one is just asking for the kinetic energy when it's at its lowest point. And in that case, since this height from here, it doesn't go to the bottom here, it's from here to here, all of this potential energy has been converted into kinetic energy. So this question, actually, the way they ask it is pretty straightforward because all of the potential energy is converted into kinetic energy. And the question is simply asking for what's its kinetic energy at the bottom. So really, this is just an MGH question because all of this is converted into kinetic energy. So it is 2.5 times 9.81 times 0.308. Don't forget to convert that to centimeters to meters. Multiply it all together, and you end up getting 7.55. D. Now, if they did ask you for the velocity, and this is more than likely, on your test, you're going to get a question with a pendulum that asks you for the velocity, then you can do it a couple of ways. One, now that you know the kinetic energy, you can just say EK equals 1/2 mv squared, right? And plug in your 7.55, 1/2 m, and solve for v squared. But the other way you can do this, probably the preferred way, is to just do the question from scratch. Because all of the potential energy is converted into kinetic energy, when we expand this formula, the mass actually becomes irrelevant. And you just get that. If you solve for velocity, you just get velocity equals the square root of 2gh. So if they're asking you for velocity, you can do it both ways. They're both going to give you the same answer. But this way is really, that's a very efficient way to solve this problem because, as I said, the mass becomes irrelevant and you're left with just the square root of 2gh. Let's just do that quickly. Square root of 2 times 9.81 times the height, 0.308, and the brackets equals 2.546. So that's the if they're asking for velocity, that's how you're going to do it. On to number 19. Number 19 is a power question. A lawnmower engine has a power output of 3.75 kilowatts. So P, the power, equals 3.75 times 10 to the 3 watts because of the kilowatts. How long, how much time will it take for the engine to do 5.6 times 10 to the 5 joules of work? Very straightforward question. Here's your formula. There's your formula rearranged for T because they're asking how long, and then it's just the 5.6 times 10 to the 5 divided by 3.75 times 10 to the 3, and that should give you an answer of A. So that's a pretty straightforward question. Number 20. Number 20 says an airplane is traveling at a constant velocity of 275 kilometers per hour east. If the friction exerts a force of 4.6 times 10 to the 3 newtons west on the plane, what is the power output of the propeller? So this is again a power question, but it's the question that we derived. We have power equals, let's go over the whole thing. Well, let's see, what do they give you in this question? They give you a velocity, 275 kilometers per hour, which equals 275 divided by 3.6 is 0.39 meters per second. So they give you a velocity and they give you force. When you see those two variables in the question, you should say, oh, we derived a formula that has velocity and force and then is asking for power. So power is what they're asking for. And how do we derive that formula? We started with this formula here, and then we combined it with, this formula here. And then we took our force times distance and replaced this. Since work equals force times distance, we can substitute that in. Force times distance over time instead of work. And then we recognize that distance over time is the same as velocity. So then we end up transforming this formula into P equals force times velocity. And once you've figured that out, then it's just a matter of multiplying those two numbers together. So we have that times 4.6 E3 equals 351.389 watts, which is going to be 351 kilowatts. So the answer is C. All righty then. Onward. Now, question 21. On your test, you should see a big omit because there's a number missing in that question. They have to give you the mass or the radius in that question. So omit that question, and you won't get one like that on your test. On to question 22. Question 22 says a 56 kilogram mass is traveling in a circle with a radius of 3.75. The frequency of revolution is 24.6 RPM. What is the centripetal force acting on the mass? Okay, so we have to ask, well, let's write down what we have. We have the mass. We have the radius. And we have the frequency of revolution. So be careful about that, about how that frequency is expressed, because it's not expressed in hertz, is it? Hertz is cycles per second. This is expressed in revolutions per minute. So the frequency equals 24.6 RPM, but that is not cycles per second. Frequency is cycles per second, hertz. So if we need that, we're going to have to change that. Well, actually, let's just do that for the sake of doing it. If we're given 24.6 cycles, revolutions, per minute, that would mean per 60 seconds. The question is, if we want this actually as a frequency, then we would say, how many cycles does it make in 1 second? And then we would cross multiply and divide, and we would get x equals 24.6 divided by 60 is 0.41 cycles per second, or hertz. And then if you want to find the period of that is 1 over the frequency. So 1 divided by the answer, and that would give us 2.4 seconds per cycle. So let's just review. The frequency is cycles per second, and period is seconds per cycle. Okay, anyway, now back to the question. What's the question asking? The question is asking for, what is the centripetal force acting on the mass? So what formula do we have for centripetal force? This is it. It's not on your formula sheet, but it's totally a formula that you should memorize because you'll use it again and again in physics 20 and 30. So what do we need to find here? We need to find the centripetal force, we need to find the velocity. How are we going to find the velocity? We have the mass, the radius, and the frequency or the period. So let's think which formula will give us the velocity. The velocity in circular motion is this one here, 2 pi r over t. So we can calculate the velocity using this formula. So that's just going to be 2 times pi. What was the radius? 3.75. And there's our period, 2.44. 2 times pi times 3.75 divided by 2.44 equals, our velocity is 9.66 meters per second. And once we've calculated the velocity, we can go back up to here. And calculate the centripetal force. 56 times 9.66 squared divided by 3.75. And we get an answer of 1,393 newtons. So it looks like the answer is D. D. Okay, actually, the next question is going to take quite a bit of work, so we'll stop there. Looks like we're doing 5 parts for this video.